हेलो स्टूडेंट्स, वेलकम टू दिस लेक्चर। थंबनेल देख के आपको आइडिया आ गया होगा दैट टुडे इन दिस लेक्चर वी आर गोइंग टू डिस्कस ऑल 15 क्वेश्चंस फ्रॉम द चैप्टर रोटेशनल मोशन दैट केम इन जेडब्ल्यू मेंस अप्रैल 2025 शिफ्ट। ये लेक्चर थोड़ा सा लेंदी होने वाला है, सो आई विल सजेस्ट आप स्टार्ट टू एंड इसको पूरा देखिए। And since we are going to solve all these 15 questions in quite detailed manner, so honestly ये lecture आपका complete rotational motion का revision ही हो जाएगा। Alright, so let's get started. A rod of length 5L is bent right angle keeping one side length as 2L. The position of the center of mass of the system. Consider L is equals to 10 centimeter. Option A 5I cap plus 8J cap. Option B 4I cap plus 9J cap. Option C 3I cap plus 7J cap. Option D 2I cap plus 3J cap. This MCQ came in JEE Mains Shift 1 7th April 2025 examination. The total length is given to you as 5L. It is bent at right angle in such a way that horizontal rod is having length 2L while vertical rod is having length 3L. Diagram भी आपको guide करेगा इसके लिए. Alright. Now the value of L given to you is 10 centimeter. So can I say this 2L will be 20 centimeter and then this 3L will be 30 centimeter. Alright. So how to find out center of mass of this horizontal rod? This red dot is center of mass of this horizontal rod whose length is 2L. X1, Y1. Students, can I say this center of mass for 2L is lying on x-axis? So its y coordinate will be 0. What about the x coordinate? Yes, total length is 20 centimeter. X coordinate उसका exactly center पे होगा. Half of 20 centimeter will give you 10 centimeter. So x1, y1 is 10, 0. Alright. For this vertical rod, center of mass will be over here. Its coordinates are labeled as x2, y2, sir. Alright. So this point is lying on y-axis. So its x coordinate will be 0. What about the y coordinate, students? Half of this 30 centimeter should give you 15 centimeter. So x2, y2 is 0, 15. Clear? What about masses? Horizontal rod mass will be m1. Students, m1 आप मुझे बता सकते हैं कितना होगा? Can I say length is 10 centimeter? Let me assume for this length 10 centimeter, the mass is m. So can I say for this 20 centimeter mass will be 2m? Here I have to assume that linear density is constant for the rod. Mass per unit length remains the same. So for length L, right, the value is 10 centimeter. Mass I am considering as m. So for length 20 centimeter it should be doubled, right? It should be 2m. And same way for this 30 centimeter length it should be tripled of m, that is 3m, sir. So m1 हो गया 2m, right? What about m2, mass of this vertical rod? Tell me. It will be 3 times m. How you calculate center of mass x coordinate, right? X coordinate center of mass, sir. m1 x1 plus m2 x2. The whole over total mass of the system is m1 plus m2. Alright, students, what is the value of m1? 2m. x1 10 plus m2 3m multiplied by x2 0 divided by total mass, students, 2m plus 3m. Alright, that should give you 20m plus 0 the whole over 5m. So m will get cancelled. In the next step you should be getting 4, right? 4 centimeter. So center of mass x coordinate is equals to 4 centimeter. What about center of mass y coordinates, sir? YCOM, tell me. It will be m1 y1 plus m2 y2 divided by total mass is m1 plus m2. Tell me what is m1? 2m, y1 0 plus m2 3m, y2 15, the whole over 2m plus 3m. Alright. So this is now 0 plus 45m divided by 5m. So this should give you 9 centimeters, students. So x coordinate center of mass, comma, y coordinate center of mass you got recently, that's 4 comma 9 centimeter, obviously, right? So as per the given option, it should be option B. Answer is given in terms of unit vector, right? So 4 I cap plus 9 j cap, because we all know I cap is a unit vector along x axis and j cap is a unit vector along y axis. Alright, option B is the correct answer, beta. 4 I cap plus 9 j cap. If L vector and P vector represent the angular momentum and linear momentum respectively of a particle of mass m having position vector as r vector is equals to a times cos omega t I cap plus sin omega t j cap, the direction of force is option A opposite to the direction of r vector, option B opposite to the direction of p vector, option C opposite to the direction of L vector, option D opposite to the direction of L vector cross p vector. This question came in shift 1 4th April 2025 examination. Students, the given position vector looks like this. R vector is equals to A times cos omega t I cap plus sin omega t j cap. Mind you, over here this A is not the acceleration, this A is basically a constant. Alright. So I think using this position vector we can find out velocity. Yes, velocity v vector is given by dr vector by dt, students. Velocity will be rate of change of position with respect to time. Yes, students. Over here in this equation number 1, right, r vector equation number 1, A is a constant. I can take this outside the differential sign. Yes sir. The derivative of cos omega t I cap will be minus of sin omega t into derivative of omega t, which is omega separately, unit vector I cap as it is, plus what is the derivative of sin omega t, students? It will be cos omega t into derivative of omega t, which is omega separately, multiplied by unit vector j cap as it is. So simplified version will look like A times omega I am taking common, inside the bracket I am using this, minus sin omega t I cap plus cos omega t j cap. This is the formula for velocity vector v vector. This is my equation number 2. Getting this, students? Now using velocity, how can I find out acceleration, students? Come on. Acceleration is a1 vector लिखना पड़ेगा ना, because a जो given है in equation number 1, right, वो acceleration नहीं है. So I am purposely using some other denotation for acceleration, that is a1 vector. Students, acceleration a1 vector will be rate of change of velocity with respect to time, that is dv by dt. Here a is a constant. What about omega? Constant, keep it outside derivative. Now what is the derivative of minus sin omega t, students? It will be minus of cos omega t multiplied by omega I cap unit vector as it is. Okay. Now then, what is the derivative of cos omega t, students? It will be minus sin omega t multiplied by omega unit vector j cap as it is. So what I can do now, a and omega already bracket के बाहर है. Inside the bracket I can take minus common, even omega common. So ये total omega square हो जाएगा, students. Inside the bracket you are getting now cos omega t times I cap plus sine omega t times j cap. Students, okay? So this is acceleration a1 vector. Let me consider this as equation number 3. Now do one thing. Look at equation number 3 carefully. A times, ये bracket वाला term students, cos omega t I cap plus sin omega t j cap, okay? So what I can do now? I can use equation number 1 and 2. Using equation number 1 and equation number 2, can I say acceleration a1 vector will be minus of omega square multiplied by, ये येलो वाला जो मैंने अभी अभी हाईलाइट किया, कैन आई से a टाइम्स cos omega t I cap plus sin omega t j cap is your equation number 1 only. So I can replace that by r vector. Getting this, students? So using 1 and 2, I got the conclusion that acceleration is minus of omega square multiplied by r vector. Can I say, students, force F vector is mass times acceleration? So this will be mass multiplied by a1 vector. So that is minus of m omega square multiplied by r vector. Getting this, students? Using this recent equation, आपको समझा F vector is minus of m omega square times r vector, right? So this negative sign will help you to understand that the two vectors, one on LHS and one on RHS, are anti-parallel vectors, okay? So F vector and R vector, right? That is force and position vector are anti-parallel vectors. That means, students, the angle between force and position vector will be 180 degree. So that means your answer should be option A, students. The direction of force is opposite to that of direction of r vector. Alright, completed. Which of the following are correct expression for torque acting on a body? Formula A, tau is equals to r cross L. Formula B, tau equals to d by dt of r cross P. Formula C, tau equals to r cross dp by dt. Formula D, tau is equals to I alpha. Formula E, tau equals to r cross f. It is given that r is position vector, p is linear momentum, L is angular momentum, alpha is angular acceleration, I is denoting moment of inertia, f is the force and t is time. Choose the correct answer from the following options given below. Option A, B, C, D and E only. Option B, C and D only. Option C, A, B, D and E only. Option D, B, D and E only. Alright, students, tau is equals to R cross L ऐसा होता है क्या? बिल्कुल नहीं होता है सर. टाउ वेक्टर होता है, टाउ वेक्टर होता है, वेरी फेमस फॉर्मूला, हमने लेक्चर में भी कंसिडर किया हुआ है ये, राइट? टाउ वेक्टर इज इक्वल्स टू आर वेक्टर क्रॉस एफ वेक्टर. यस सर, नो सर? यस सर. So tau is equal to r cross L, where L is angular momentum. This is false. This is false. Alright, students, look at formula B. Formula B में given है tau is equals to d by dt of, tell me, r vector cross p vector, and yes, we all know this is tau vector. Alright, इसमें आप क्या करो? According to me, student, this formula is true. Now in case you are not knowing, एक बार सुन लो कैसे हैंडल करना है इसको. So tau vector is d by dt of r vector cross p vector. I am going to apply UV rule of my mathematics differentiation, right? So this is r vector cross dp vector by dt plus dr vector by dt cross p vector. Correct है ना students? One term as it is and you take derivative of second, then vice versa second time, and बीच में प्लस का साइन डालना होता है. करेक्ट है? ऑलराइट, बी ए गुड ऑब्जर्वर. हाँ बेटा, अभी tau vector is r vector cross dp vector by dt. Alright, plus, students, what about dr vector by dt? That's v vector cross with p vector, linear momentum is m times v vector. Yes, So the simplified version looks like tau vector is equals to r vector cross dp vector by dt plus, just be a good observer students, as I told you recently, m बाहर ले सकते हो, mass is a scalar quantity, multiplication में you are going to obtain here v vector cross v vector. Now students, v vector and v vector are two parallel vectors, and for parallel vector what is the answer of cross product, tell me? This will be 0 beta, this will be 0, and that is the reason मैं कह सकता हूँ that tau vector is equals to r vector cross dp by dt, प्लस तो 0 ही है स्टूडेंट्स, एंड लेटर ऑन आप यही टाउ वेक्टर को लिख सकते थे r vector cross, tell me what is dp by dt? Sir, this is nothing but force, very famous formula, right? Tau vector is equals to r vector cross f vector. So tell me b ट्रू हुआ कि नहीं? बाय अज्यूमिंग b दैट वो करेक्ट है, हमने पूरा आपको सॉल्व करके दिखाया. क्या क्या समझा स्टूडेंट्स आपको? टाव इज r क्रॉस f, सो ऑब्वियसली फॉर्मूला e हो चुका है ट्रू, राइट? टाव इज इक्वल्स टू आई अल्फा, हमारे रोटेशनल मोशन का स्टैंडर्ड फॉर्मूला. यू कैन स्टिल कंफर्म विथ योर ट्रांसलेटरी मोशन. f इज इक्वल्स टू मास टाइम्स एक्सीलरेशन, कंपेयर विथ f इज इक्वल टू ma, इन केस रिकलेक्ट नहीं हो रहा है. टाव इज आई अल्फा, दिस इज ऑब्वियसली ट्रू. सोचना है हमको अबाउट फॉर्मूला सी. बोलो बेटा, टाव वेक्टर इज आर वेक्टर क्रॉस dp वेक्टर बाय dt, इज इट करेक्ट? yes sir, that is correct. Tau vector is r vector cross dp vector by dt, right? so ये भी तो true हो गया ना students. so I think formula B, formula C, formula D, formula E all are correct. so this is going to match with option A, correct? option A में it is given that B, C, D and E all this are correct. A तो false हो गया ना बेटा, alright? ए मतलब मैं फॉर्मूला ए की बात कर रहा हूँ. फॉर्मूला ए फॉल्स हो गया, ऑप्शन ए इज करेक्ट, जिसमें बताया जा रहा है फॉर्मूला बी, फॉर्मूला सी, फॉर्मूला डी एंड फॉर्मूला ई आर करेक्ट. ऑप्शन ए तुम्हारा आंसर है. ओके, द मोमेंट ऑफ इनर्शिया of a circular ring of mass m and diameter r about a tangential axis lying in the plane of the ring is option A 3 by 8 mr square, option B 3 by 2 mr square, option C 2 mr square, option D 1 by 2 times mr square. This question came in 2nd April shift 2 2025 JEE mains examination. Now students, it's about a ring. Let me draw that ring for you. Alright, we all know at this level that moment of inertia about central axis IC, right, will be mr square. Yes sir, no sir? For a ring, moment of inertia about central axis will be mr square. Okay, now can I say अबाउट द डायामीटर ऑल्सो हम उसका मोमेंट ऑफ इनर्शिया कैलकुलेट कर सकते हैं? कैन आई डू दैट? लेट मी कंसिडर दैट अबाउट द डायामीटर जो दो एक्सिस है, दोज टू एक्सिस आर एक्स एंड वाई एक्सिस. सो आई कैन यूज ओवर हियर स्टूडेंट्स परपेंडिकुलर एक्सिस थ्योरम, करेक्ट? इट्स अबाउट यूजिंग परपेंडिकुलर एक्सिस थ्योरम. As per that perpendicular axis theorem, we know that Iz, moment of inertia about z axis, will be moment of inertia about x axis plus moment of inertia about y axis. Properly सारे conditions satisfy हो रहे हैं, right? So instead of Iz आप क्या लिख सकते हो? आप लिख सकते हो Ic, right? That is equals to, instead of Ix आप लिख सकते हो moment of inertia about diameter axis. Same way Iy you can replace by Id. Can you do that? Moment of inertia about the diameter axis, students. Yes. So Ic, which we already know, this is mr square, is equals to Id plus Id, that is 2 times Id, students. So Id, moment of inertia about the diameter axis, will be half mr square. Is that fine, students? I am going in a stepwise manner so that सारे students cope up कर सके. मैक्सिमम स्टूडेंट्स ने तो ऑलरेडी ये रिजल्ट ही याद कर लिया होगा, तो और अच्छी बात है, आपका टाइम सेव होगा स्टूडेंट्स यहाँ पे, राइट? आप मुझे बताइए मोमेंट ऑफ इनर्शिया अभी भी जो आपको मिला अबाउट डायमीटर एक्सिस ID, that is how much? Half mr square. Yes sir. Moment of inertia about diameter axis id will be half mr square. यहाँ तक सब ठीक है students? Getting this? Now, how I calculate moment of inertia about tangential axis but in the plane? It is not perpendicular to the plane, right? तो recently जो मैंने blue वाला axis आपके सामने draw किया, let me do this modification. Recently students जो मैंने आपके सामने ये black वाला axis draw किया, उसके about का मुझे moment of inertia ढूंढना है. क्या कहते हैं हम इसे? Moment of inertia about an axis which is tangent in the plane. ITP याद आ रहा है? रेगुलर क्लास में बताया था मैंने आपको. ITP, moment of inertia about tangential axis in the plane, not perpendicular to the plane, in the plane, right? So ITP students will be equals to moment of inertia about diameter axis plus m times h square. So recently मैंने क्या यूज़ किया students आपके सामने while framing this black वाला formula? ITP is equals to ID plus mh square. बोलो कौन सा थ्योरम यहाँ पे? It is this time parallel axis theorem. Yes or no sir? Yes sir, this is parallel axis theorem. Alright? अच्छा sir. So students, moment of inertia about an axis which is tangent and parallel to that ring will be moment of inertia about diameter ID is half mr square plus m times h square. h होता है students दोनों पैरेलल एक्सिस के बीच का परपेंडिकुलर डिस्टेंस विच इज़ नथिंग बट रेडियस ऑफ द रिंग, राइट? सो दिस इज एम आर स्क्वायर. सो टोटल आई टी पी जो आपका रिक्वायरमेंट है दैट विल बी 3/2 एम आर स्क्वायर. 3/2 एम आर स्क्वायर. मैक्सिमम स्टूडेंट्स ने ये रिजल्ट को डायरेक्टली याद रखा होगा एंड मैं तो कहता ही हूँ कि आपको याद रखना है. इन केस यू नीड द प्रूफ, आंसर आपके सामने, प्रूफ आपके सामने, राइट? सो मोमेंट ऑफ इनर्शिया अबाउट एन एक्सिस which is tangent and parallel to that plane will be ITP 3/2 mr square. बोलो कितना लिखूँ मैं? 3/2 mr square. समझ में आ रही है स्टूडेंट्स? इट विल बी बोलो 3/2 mr square. Okay students, so required answer is, let me complete this last step now, will be ITP is equals to 3/2 times mr square. but यहाँ पे there is a catch. जो diameter है ना students in this question वो दिया हुआ है स्मॉल आर. माइंड यू यहाँ स्मॉल आर इज नॉट द रेडियस ऑफ द रिंग, स्मॉल आर इज डायमीटर ऑफ दिस रिंग, राइट? सो दिस विल बी ITP जो आपने ढूंढा रिसेंटली, दिस विल बी स्टूडेंट्स 3/2 टाइम्स m. इंस्टेड ऑफ रेडियस का स्क्वायर आप लिख सकते हैं. रेडियस क्या होगा स्टूडेंट्स? हाफ ऑफ डायमीटर. डायमीटर है वो स्मॉल आर है, राइट? सो इट इज स्मॉल r by 2. गेटिंग दिस? सो रेडियस इज नॉट छोटा r here. Here diameter is छोटा r, so radius will be half of that छोटा r. Getting this? So this ITP will be like 3/2 into m into r square divided by 2 square will give you 4, right? 2 square will give you 4 over here. So this answer will look like ITP जो आपका requirement है. This will be students 3/8 multiplied by mr square. Alright student, this will be, come on, 3/8. समझ में आ रही बात? 3/8 mr square. 3/8 mr square and that's why this is going to match with option A students. Complete this. Required answer is 3/8 mr square. This is your option A. Easy? A rod of linear mass density lambda and length L is bent to form a ring of radius r. Moment of inertia of ring about any of its diameter is option A lambda L cube divided by 8 pi square, option B lambda L cube divided by 4 pi square, option C lambda L cube divided by 16 pi square, option D lambda L cube divided by 12. Alright, so student, this question came in first shift 8th April 2025 JEE mains examination. The question goes like this: there is a rod, okay, whose length is L and its linear mass density is considered as lambda. Alright, it is bent in the form of a ring. So this rod is converted into a ring. Getting this? Okay. Now it is quite obvious that recently जो length of the rod था, now that has become circumference of this ring, which is 2 pi r. So L will match with 2 pi r. Getting the students? And lambda is given to you. What is lambda for the rod, students? It is mass per unit length. What do you mean by linear mass density? It is mass per unit length only. Alright, तो मुझे बता सकते हैं आप मास का रिप्लेसमेंट क्या होगा? लैम्डा टाइम्स एल. So instead of mass, I can use lambda times L, and then instead of length, I can use 2 pi r, or vice versa for this. Instead of r, I can use L divided by 2 pi. If I can compare the options, कहीं पर भी radius given नहीं है. So it is quite obvious मुझे r को replace करना पड़ेगा in terms of length. करते हैं, not a big deal. But उसके पहले I have something important to discuss. What they are actually demanding, tell me students. Moment of inertia of ring about any of its diameter, right? So for the ring, students, about any of its diameter, let's say this is the diameter of that ring, about this axis moment of inertia will be id, right? For the rod it will be half mr square. Getting the students? 1 by 2 mr square. So this will be 1 by 2. Instead of mass, I can use this equation number 1. I can say that mass is lambda times L, alright? And then using equation number 2, I have to replace radius there, square will remain as it is. Instead of radius, I can use L divided by 2 pi using equation number 2. Getting this? Let me simplify this, right? So this will look like half lambda L multiplied by L square divided by 4 pi square. So overall this will look like, students, lambda times L cube divided by 2 into 4 will give you 8 pi square. So the correct answer is ID for the ring, right? Moment of inertia along one of the diameter of the ring, that is ID, is equals to lambda L cube divided by 8 pi square. So lambda L cube divided by 8 pi square. So this is going to match with, students, option A. Alright, complete this numerical. Lambda L cube divided by 8 pi square. Okay, easy था आपके लिए, right? Moment of inertia of a rod of mass m and length L about an axis passing through its center and normal to its length is alpha. Now the rod is cut into two equal parts, and these parts are joined symmetrically to form a cross shape. Moment of inertia of cross about an axis passing through its center and normal to plane containing cross is option A alpha, option B alpha by 4, option C alpha by 2, option D alpha by 8. Students, moment of inertia for a rod about central axis, it's a standard formula I see, right? It is ml square by 12. All of you know this. Now as per the data, ये जो ml square by 12 है, this I have to replace by alpha. Yes students? So ml square by 12 is actually the value of alpha. This is like case number 1, students, C1. Okay. Now what's new in case number 2, students? Rod is cut into two equal parts, right? And these parts are joined symmetrically to form a cross shape. So diagram will look somewhat like this. Total जो rod है first वाला, its length is m. Yes sir, its length is L. My bad, its length is L and the mass is m. अब सही बोल रहा हूँ मैं. Length of the rod is L and its mass is m. करना क्या है? You have to cut this rod into two equal parts such that हर एक का जो length है वो हो जाएगा L by 2 L by 2. अब ये जो ब्लू वाला सिस्टम आपको दिख रहा है स्टूडेंट्स, ब्लू वाला, राइट, इसके ये जो क्रॉस फॉर्म हो रहा है, इसके सेंटर से आपका एक्सिस शुड पास. सो इसका मोमेंट ऑफ इनर्शिया इज, लेट्स से आई डैश, ये आपको ढूंढना रहेगा. सो स्टूडेंट्स, आई डैश विल बी मोमेंट ऑफ इनर्शिया ऑफ सिंगल स्मॉल रॉड विल बी m L square by 12, basic is still the same. वन सिंगल रॉड का मोमेंट ऑफ इनर्शिया आई डैश अगर आपको कैलकुलेट करना है दैट विल बी एम एल स्क्वायर बाई 12. एम इज बाय द वे हाफ ऑफ द टोटल मास विच इज एम बाई 2 एल स्क्वायर एज कंपेयर टू द एंटायर रॉड. हाफ रॉड का लेंथ हाफ है दैट इज एल बाई 2 है स्टूडेंट्स. सो इट इज मास एम बाई 2 इंटू लेंथ का स्क्वायर विच इज एल बाई 2 का स्क्वायर डिवाइड बाई 12. Now we all know at this level that moment of inertia is a scalar quantity, correct? So moment of inertia of the entire system in case 2 is I dash, which is found by m by 2 into L by 2 the whole square divided by 12 multiplied by 2. क्यों multiplied by 2? Total there are two similar rods. एक का आपने कैलकुलेट किया, दूसरे का सेम होगा. So for the entire system आप सिंगल निकालिए, उसको 2 से मल्टीप्लाई करिए. Logical? So this I dash will be students m by 2 into L square divided by 4 into 2 the whole over 12, correct? So this will be like 2 getting cancelled, obvious. So this moment of inertia for the new system in case 2 I dash is students ml square divided by 48. But students, as you can observe, the options are in terms of alpha. नो प्रॉब्लम सर, आप इसको लिख सकते हो एम एल स्क्वायर बाई 12 द होल अपॉन 4, वन एंड द सेम थिंग कर सकते हैं ऐसा. एंड एम एल स्क्वायर बाई 12 इज नथिंग बट द वैल्यू ऑफ अल्फा गिवन टू यू. सो दिस इज लाइक अल्फा डिवाइड बाई 4. सो फॉर द न्यू सिस्टम द मोमेंट ऑफ इनर्शिया आई डैश इज 1/4 ऑफ अल्फा, 1/4 ऑफ अल्फा, एंड दिस इज गिवन स्टूडेंट्स इन ऑप्शन बी. सो दिस इज योर आंसर, ऑप्शन बी alpha by 4. Completed? Option B alpha by 4. Option B alpha by 4. Complete there students. A wheel of radius 0.2 meter rotates freely about its center when a string that is wrapped over its rim is pulled by force of 10 Newton as shown in figure. The established torque produces an angular acceleration of 2 radian per second square. Moment of inertia of the wheel is dash kg meter square. Acceleration due to gravity is equals to 10 meter per second square. This question came in shift 2 2nd April 2025 JEE mains examination. Alright, so in this question students, as per the data, the value of alpha is equals to 2 radian per second square. Yes students, the wheel will be rotating in this direction, right? So looks to be a simple question based on the formula of tau. Do we all know the basic formula for torque tau is equals to I times alpha, where I is moment of inertia and alpha is angular acceleration, जिसका वैल्यू आपको गिवन है 2 रेडियन पर सेकेंड स्क्वायर. सो व्हाट वी कैन डू, हम लोग टॉर्क का एलिमेंट्री फार्मूला यूज़ कर सकते हैं स्टूडेंट्स. द बेसिक फार्मूला फॉर टॉर्क टाउ विल बी एफ मल्टीप्लाइड बाय आर परपेंडिकुलर. लुक एट द क्वेश्चन, लुक एट द डायग्राम, राइट? क्या आपको ये समझ में आ रहा है दैट फोर्स यू आर अप्लाइंग along the tangent to the wheel, right? So by default ये जो एंगल है स्टूडेंट्स, फोर्स एंड रेडियस ऑफ द व्हील के बीच का वो 90 डिग्री है. सो इंस्टेड ऑफ सेइंग f इंटू आर परपेंडिकुलर, नाउ आई कैन से इट इज f मल्टीप्लाइड बाय r, where r is radius there, alright? So f into r will give you students I times alpha. The requirement is moment of inertia I, right? So fr divided by alpha can give you moment of inertia I, obvious. Now let's substitute those values here. I think आपका काम फटाफट हो जाना चाहिए. Moment of inertia I students will be Fr by alpha. What is the value of F? Yes, 10 Newton multiplied by R, radius is 0.2 meter divided by alpha is 2. So this will give you students 2 by 2, that is 1. Yes, moment of inertia is 1 kilogram per meter square. So जो ब्लैंक गिवन है स्टूडेंट्स, वहाँ पे आपको पुटअप करना रहेगा 1. सो दिस इज इंटीजर टाइप क्वेश्चन जहाँ पे आंसर आ जाएगा स्टूडेंट्स 1. ओके, कंप्लीट दिस क्वेश्चन. द मोमेंट ऑफ इनर्शिया ऑफ द व्हील इज देयरफॉर 1 किलोग्राम मीटर स्क्वायर. ओके, M and R be the mass and radius of a disk. A small disk of radius r by 3 is removed from the bigger disk as shown in figure. The moment of inertia of remaining part of bigger disk about an axis AB passing through the center O and perpendicular to the plane of the disk is 4mr square divided by x. The value of x is how much? This question came in shift 2 7th April 2025 examination. First of all students, what we are going to discuss, moment of inertia of the original disk, that is bigger disk. Yes, moment of inertia of the bigger disk, that is original disk जिसका radius r है, about central axis. समझा बेटा आपको? सेंट्रल एक्सिस पासिंग थ्रू सेंटर O एंड परपेंडिकुलर टू द प्लेन ऑफ द डिस्क. सेंट्रल एक्सिस, राइट? दैट इज डायरेक्टली m r square by 2. obvious. Let's say this is equation number 1. Moment of inertia original value is equals to mr square divided by 2. Okay, now let's find out moment of inertia of the cavity, or you can say moment of inertia of the स्मॉलर डिस्क. आपके स्टेटमेंट को अगर आप रीड करें तो ऐसा बताया जा रहा है, अ स्मॉल डिस्क ऑफ रेडियस r by 3, राइट? तो क्या करते हैं, स्मॉल डिस्क ही लिखते हैं स्टूडेंट्स. सो मोमेंट ऑफ इनर्शिया ऑफ द स्मॉल डिस्क, समझा आपको? कौन सा? ये वाला स्टूडेंट्स जिसका रेडियस गिवन है ना आपको r by 3, ये छोटा वाला जिसका सेंटर दिया हुआ है O डैश. कैन आई से वो मोमेंट ऑफ इनर्शिया निकालने के लिए फर्स्ट ऑफ ऑल यू शुड नो व्हाट इज द मास एंड व्हाट इज द रेडियस. No problem for its radius. Radius is directly given to you. It's r by 3. मास के लिए आपको थोड़ा सॉल्विंग करना पड़ेगा. स्टूडेंट्स टेल मी वन थिंग. कैन आई से दिस इज अ डिस्क, राइट? सो सरफेस डेंसिटी you can assume to be constant. Can you do this? Surface density, which is denoted by sigma, is going out to remain constant. Yes students? Now the basic formula for surface density sigma looks like mass per unit area. Obvious students? Mass per unit area. So basically मैं आपसे ये कह रहा हूँ, sigma is remaining constant, so mass upon area will remain constant. That means mass will be directly proportional to area. Can I do this? Disk है ना students, 2D structure है ना, that's why I am using the knowledge of sigma. अगर ये एक सॉलिड स्फीयर होता लेट्स से, तो आप 3D स्ट्रक्चर के बारे में सोचते, तो वहाँ पे आप बोलते वॉल्यूम डेंसिटी रो विल रिमेन कांस्टेंट, बट हियर डिस्क इज गिवन टू यू 2D स्ट्रक्चर, सो सिग्मा दैट इज सरफेस डेंसिटी विल रिमेन कांस्टेंट. करेक्ट है स्टूडेंट्स? इतना समझा आपको? नाउ टेल मी वन थिंग, एज कंपेयर टू द बिगर डिस्क, स्मॉलर जो डिस्क है उसका रेडियस कैन आई से 1/3 है. स्टूडेंट समझ में आ रही है बात? सो रेडियस इज 1/3. yes sir, so radius of smaller disk is 1/3 as compared to radius of the bigger disk. ऐसे compare कर सकते हैं. So what about area students? Basic formula for area will be pi times radius square. If radius is 1/3, right, so area will be 1/9. All of you agree with this? Because area will be pi r square, area will be 1/9 times. That means as compared to बड़ा disk, छोटे डिस्क का जो एरिया है वो 1/9 टाइम्स है. बट सर रिसेंटली आई वॉज एक्सप्लेनिंग यू मास ऑफ द डिस्क इज डायरेक्टली प्रोपोर्शनल टू एरिया. सो इफ एरिया ऑफ द स्मॉलर डिस्क इज 1/9 टाइम्स एज कंपेयर्ड टू एरिया ऑफ द बिगर डिस्क, कांट आई से मास ऑफ द स्मॉलर डिस्क, राइट, इज ऑल्सो 1/9 टाइम्स मास ऑफ द बिगर डिस्क. समझ में आ रही है बात? दिस इज इंपॉर्टेंट कंक्लूजन स्टूडेंट्स. सिग्मा विल रिमेन कॉन्स्टेंट, वो नॉलेज आप यूज़ करेंगे. सो यू विल कम टू नो दैट मास ऑफ द स्मॉलर डिस्क इज 1/9 टाइम्स मास ऑफ द बिगर डिस्क. मास इज 1/9 टाइम्स. ये समझा? 1/9 टाइम, राइट, 1/9 टाइम. गेटिंग दिस? या मुझे इसको ऐसे भी लिख के देना पड़ेगा आपको? मास ऑफ द स्मॉलर डिस्क इज इक्वल्स टू 1/9 टाइम्स mass of the bigger disk, yes sir. Now mass of the bigger disk, I think it is m only. ये चेक करो, m फॉर्मूला भी हमने अकॉर्डिंगली फ्रेम किया है, इक्वेशन नंबर 1, राइट. सो मास ऑफ द स्मॉलर डिस्क, mass of the smaller disk is equals to m by 9, obvious, m by 9 times m by 9. Getting the students? Now after this आप क्या करना, आप है ना मोमेंट ऑफ इनर्शिया कैलकुलेट करना स्टूडेंट्स. मुझे बताओ मोमेंट ऑफ इनर्शिया ऑफ दिस स्मॉल डिस्क कैसा होगा. For disk, moment of inertia about central axis passing through center perpendicular to plane, right, will look like mr square by 2, correct, mr square by 2, mr square by 2. बट वहाँ पे एक प्रॉब्लम होगा स्टूडेंट्स, आपको यूज़ करना पड़ेगा पैरेलल एक्सिस थ्योरम, राइट. बिकॉज आप जो एम आर स्क्वायर बाई 2 यूज़ करेंगे, डेफिनेटली मास छोटे डिस्क का यूज़ करेंगे, रेडियस भी छोटे डिस्क का यूज़ करेंगे, मैं मना नहीं कर रहा हूँ, राइट. बट आपको पता है आप जो एम आर स्क्वायर बाई 2 यूज़ करेंगे फॉर द स्मॉलर डिस्क, वो होगा अबाउट सेंट्रल ओ डैश. बट आपको तो अबाउट ओ ढूंढना है ना स्टूडेंट्स. सो फर्स्ट चलिए स्टेप वाइज करते हैं स्टूडेंट्स, नो प्रॉब्लम. मैं स्टेप वाइज जाऊँगा. मुझे बताओ मोमेंट ऑफ इनर्शिया ऑफ स्मॉल डिस्क, राइट, अबाउट ओ डैश, राइट. उसका खुद का सेंटर देखो, ओ डैश विल बी एम आर स्क्वायर बाई 2, ऑब्वियस. व्हाट इज इट्स मास, इट इज m बाई 9 टाइम्स. समझ में आ रही है बात स्टूडेंट्स. अबाउट ओ डैश, ये जो सेंटर है स्टूडेंट्स, छोटे डिस्क का मोमेंट ऑफ इनर्शिया हम निकाल रहे हैं. वही सेंट्रल एक्सिस पासिंग थ्रू सेंटर परपेंडिकुलर टू प्लेन ऑफ द डिस्क, mr स्क्वायर बाई 2, बट द मास इज m बाई 9 टाइम्स, राइट. इनटू उसका रेडियस क्या दिख रहा है स्टूडेंट्स तुमको, r बाई 3. द होल स्क्वायर विल रिमेन एज इट इज. in fact r by 3 the whole square as it is, the whole upon 2, ठीक है. so this will look like students after solving, आपको समझेगा, this is m, right, into r square divided by students 9 into 3, in fact 3 square 9, 9 into 9 81, 81 का डबल आप करोगे आपको मिलेगा 162. यहाँ तक सब ठीक है स्टूडेंट्स. एम आर स्क्वायर बाई 2 यूज़ कर लिया तुमने फॉर द स्मॉलर डिस्क, बट दिस इज अबाउट सेंटर ओ डैश. Now there comes the modification, and this is the most important step of this numerical. Can I say moment of inertia of small disk again, right, small disk again about O dash, in fact about O. Actually आपको पूछा है about O, O is the actual center, right. So moment of inertia about O will be students moment of inertia about O dash प्लस m टाइम्स h स्क्वायर. बोलो येस और नो. एक काम करते हैं, स्मॉल m लिखते हैं सो दैट देर इज नो कन्फ्यूजन फॉर यू, राइट. सो मोमेंट ऑफ इनर्शिया ऑफ अ स्मॉल डिस्क अबाउट o विल बी आई नॉट डैश या फिर आई ओ डैश प्लस एम एच स्क्वायर. बोलो क्या है स्टूडेंट्स ये, दिस इज योर पैरेलल एक्सिस थ्योरम. गेटिंग दिस स्टूडेंट्स, या ये भी मुझे स्टेप वाइज बताना पड़ेगा आपको. पैरेलल एक्सिस थ्योरम मेरे को रिसेंटली यूज़ करना पड़ेगा. ये स्टूडेंट्स एज पर, लेट मी रिमाइंड यू, एज पर पैरेलल एक्सिस थ्योरम, इन केस देयर इज़ अ कन्फ्यूजन. सुनो मेरी बात ध्यान से स्टूडेंट्स. आई नॉट को आप कहते हो आई नॉट, राइट, इज इक्वल्स टू आई सी प्लस एम इंटू एच स्क्वायर. बोलो येस और नो. आई सी मोमेंट ऑफ इनर्शिया अबाउट सेंट्रल एक्सिस, आई नॉट इज मोमेंट ऑफ इनर्शिया अबाउट एन एक्सिस जो आपको ढूंढना है. बट द कैच इज ये दोनों एक्सिस कैसे होने चाहिए, ऑब्वियसली पैरेलल. m इज द मास, h इज द परपेंडिकुलर डिस्टेंस बिटवीन द टू पैरेलल एक्सिस. यहाँ तक सब ठीक चल रहा है स्टूडेंट्स, ठीक है. सो मोमेंट ऑफ इनर्शिया अबाउट ओ, आई ओ कंसिडर कर लूँ मैं किसका, ऑब्वियसली स्मॉल डिस्क का जो तुम निकाले उसका खुद का, राइट. दिस इज आई ओ डैश. मोमेंट ऑफ इनर्शिया अबाउट ओ डैश आपको पता है कितना है स्टूडेंट्स, ये चेक करो, दिस वन एम आर स्क्वायर बाई 162 स्टूडेंट्स. दिस विल बी एम आर स्क्वायर बाई 162 प्लस मास मल्टीप्लाइड बाय एच स्क्वायर. सर व्हाट इज द वैल्यू ऑफ मास, कम ऑन, दैट्स नॉट एम. बेटा मैं छोटे डिस्क की बात कर रहा हूँ, हुज मास इज, कम ऑन, पता है ना आपको, हुज मास इज m बाई 9 टाइम्स. बोलो येस और नो, m बाई 9, राइट. तो मोमेंट ऑफ इनर्शिया अबाउट पॉइंट O एज द सेंटर, राइट, आई शुड से मोमेंट ऑफ इनर्शिया अबाउट ओ, जो ये मैंने डायग्राम में रेड से बनाया है, विल बी mr² by 62 जो आपने कैलकुलेट किया है, प्लस m विच इज एक्चुअली m by 9 इंटू what is the perpendicular distance between the two parallel axes, come on, देखो बेटा ध्यान से, यहाँ बच्चे मिस्टेक करते हैं, what is the radius of this bigger disk r, right, ये रेडियस कितना है छोटे डिस्क का r by 3, so this distance is h only, can I say this is r minus r by 3, yes students, that will give you 2r by 3, it's a very good question, please take it seriously, this is the required value of h, बोलो बेटा, तो h का वैल्यू क्या हो गया यहाँ पे 2r by 3, गेटिंग द स्टूडेंट्स, लेट मी एक्सटेंड दिस ईयर, मुझे बताओ मोमेंट ऑफ इनर्शिया अबाउट o, राइट, फॉर द स्मॉलर डिस्क कितना मिलेगा बोलो बेटा, दिस विल बी mr² by 162 plus m by 9 multiplied by 2r by 3 the whole square, that will give you 4r square divided by 9, in fact 3 square will give you 9, यहाँ तक clear है students? Yes, so this will look like students mr² by 162 plus this will give you 81 in the denominator and the numerator is 4mr², so this total will be students mr² by 162 plus, instead of 4 by 81 I am writing 8 by 162, I can do this, mr² remains as it is, so students this will look like 9mr² divided by 162, getting the students, so for this smaller disk, for the smaller disk moment of inertia about o आपको अभी अभी मिला एफर्ट्स डाल के 9 by 162 टाइम्स mr², यहाँ तक सब ठीक है स्टूडेंट्स? ओके, आपको ऐसा रहेगा तो आप 9 एंड 162 को कैंसिल आउट कर लो, बट पहले ये देख लो, अच्छा ये mr² by 2 ही है ना, ठीक है, तो आई थिंक कैंसिल करके फ़ायदा होना चाहिए आपको, कैन आई से दिस इज mr² स्टूडेंट्स डिवाइड बाई 9 into 1 will give you 9, 72, 9 into 8 is 72, right, so mr² by 18, so students let me consider this as next useful equation, equation number 2, ये क्या हो गया बेटा, moment of inertia of which disk, small disk about o, students about o dash तो comparatively easily मिल गया आपको, recently क्या यूज़ करना पड़ा बोलो, पैरेलल एक्सिस थ्योरम, करेक्ट है स्टूडेंट्स? मुझे बताओ व्हाट इज मोमेंट ऑफ इनर्शिया ऑफ द ओरिजिनल डिस्क, मोमेंट ऑफ इनर्शिया ऑफ द ओरिजिनल डिस्क इज mr² by 2, डू यू अंडरस्टैंड ओरिजिनल स्टूडेंट्स, जिसमें पूरा डिस्क सॉलिड है, आपने कुछ कैविटी कट नहीं किया है, ओरिजिनल मोमेंट ऑफ इनर्शिया वॉज mr² by 2 अबाउट विच सेंटर सर ओ, अब ओ के ऊपर ही फोकस करो आप, नाउ मोमेंट ऑफ इनर्शिया ऑफ स्मॉलर डिस्क जो तुम कट करके बाहर निकाले, अभी अभी आपको उसका आंसर मिला इक्वेशन नंबर 2, हाउ मच इज दैट स्टूडेंट्स, दैट इज mr² by 18, that is mr² by 18, getting the students about which point, about o only, moment of inertia original value about o mr² by 2, moment of inertia of small disk जिसका मास m by 9 है, जिसका रेडियस r by 3 है, about o क्या मिला, mr² by 18, so now they are just demanding you the moment of inertia, very important sir, the moment of inertia of remaining part of bigger disk, remaining part students, so can I say moment of inertia of the remaining part will be mr² by 2 minus mr² by 18, बोलो क्या करना चाहिए तुमको, mr² by 2 माइनस mr² by 18, यहाँ तक सब ठीक है स्टूडेंट्स, सो मोमेंट ऑफ इनर्शिया ऑफ द रिमेनिंग डिस्क, राइट, मोमेंट ऑफ इनर्शिया अबाउट पॉइंट o obviously for the remaining disk will be mr² by 2 minus mr² by 18, just I am asking you to do subtraction students, this is your equation number 1 mr² by 2, this is your equation number 2, equation number 1 mr² by 2, equation number 2 mr² by 18, getting the students, so moment of inertia of the remaining disk अबाउट विच पॉइंट ओ, हाँ बेटा ओ, पहले ओ डैश निकाला छोटे डिस्क का, देन आपने यूज़ किए पैरेलल एक्सिस थ्योरम। गेटिंग दिस? आई थिंक आप इसे अभी इजीली कर लेंगे, कोई बड़ी बात नहीं है आपके लिए ये। सो दिस विल लुक लाइक 9mr² by 18, कर सकते हैं ऐसा, माइनस mr² by 18 as it is. So student, this will look like 8mr²/18। अब जो उनका क्वेश्चन है उसको हम ध्यान से अगर रीड करें, सो दे आर गिविंग यू सम 4mr², इफ आई एम नॉट रॉन्ग, इट इज़ 4mr²/x, राइट। 4mr² कुछ तो x दिया हुआ है, तो आप एक काम करो ना, you just cancel this by 2, so 2 into 4 will give you 8, 2 into 9 will give you 18, so this is 4/9mr², students, 4/9mr², moment of inertia of remaining disk about which point O will be 4/9mr², right? But I think कुछ और given है, जैसा मैं आपको कह रहा था स्टूडेंट्स, right? They are giving you, this is 4mr²/x, have a look there, 4mr²/x, ये देखो बेटा, ये वाला हाईलाइट कर दूँ मैं, ये वाला बोल रहा हूँ मैं, ये वाला बेटा, ये दिस वन, 4mr²/x, जो मैंने रेड से हाईलाइट किया रिसेंटली, फिर से चेक करो, 4mr²/x, ओके। अब तो आ ही गया होगा बच्चों को, क्या मिलेगा सर, दिस इज 4mr²/x, दैट मीन्स द रिक्वायर्ड वैल्यू ऑफ x जस्ट बाय डायरेक्ट कंपैरिजन आपको मिल जाना है 9, राइट। सो द रिक्वायर्ड वैल्यू ऑफ x इज 9। सो लुकिंग एट द क्वेश्चन वंस अगेन, राइट, द वैल्यू ऑफ x विल बी 9, राइट। उनका मोमेंट ऑफ इनर्शिया है 4mr²/x, आपको सॉल्व करके समझा दैट अननोन वैल्यू ऑफ x इज 9। इट्स अ गुड क्वेश्चन, आई विल सजेस्ट ये वीडियो को आप फिर से देखिए, स्पेशली फॉर दिस पर्टिकुलर न्यूमेरिकल। टफ नहीं है, थोड़ा सा लेंदी है, स्टेप वाइज सॉल्व करना सीख लो बेटा आप, और कुछ नहीं। A, B and C are disk, solid sphere and spherical shell respectively with same radii and masses. These masses are placed as shown in figure. The moment of inertia of the given system about PQ axis is x divided by 15 multiplied by I, where I is the moment of inertia of the disk about its diameter. The value of x is how much? This question came in shift 1, 7th April 2025 examination. Students, A is disk, जैसा कि आप देख सकते हैं स्टूडेंट्स, PQ is the axis of rotation, right? So can I say axis PQ is actually diameter for disk A? So for A, right, moment of inertia for A will be, disk है मैं मानता हूँ, बट कौन सा एक्सिस वाला, पासिंग थ्रू द डायामीटर, या फिर आप कह सकते हैं अलॉन्ग द डायामीटर ऑफ द डिस्क। जस्ट चेक द डायग्राम वंस अगेन, PQ जो है दिस इज द ओवरऑल एक्सिस ऑफ रोटेशन ऑफ द एंटायर सिस्टम। सो कैन आई से स्टूडेंट्स, फॉर डिस्क ए, राइट, एक्सिस ऑफ रोटेशन कौन सा है, अलॉन्ग द डायामीटर। बोलो बेटा फॉर्मूला क्या होगा, it will be mr²/4। all of you know this at this level। central axis नहीं है स्टूडेंट्स के mr²/2 आएगा, it is axis which is along the diameter of the disk, right, which is mr²/4, mr²/4, ये ठीक है ना। what about B there students? B is a solid sphere, but अभी ज़रा axis of rotation देखो, is it passing through the center B? no, it is actually tangent, it is actually tangent to this solid sphere. So students, moment of inertia I for solid sphere B will be, come on, 2/5mr² plus mr², that is 7/5mr²। क्या यूज़ किया मैंने स्टूडेंट्स रिसेंटली, पैरेलल एक्सिस थ्योरम, बिकॉज जो एक्सिस है वो B जो है उससे पास नहीं हो रहा है बेटा, it is not center of the solid sphere, it is tangent to the solid sphere. So 2/5mr² plus mr², that is 7/5mr². Same way for C, I think C is a spherical shell, so it's a hollow sphere, hollow sphere. Students, hollow sphere central axis के लिए आप moment of inertia क्या बोलते हो, 2/3mr², but mind you axis of rotation for the system is not passing through C, so we have to use here parallel axis theorem. Axis of rotation is PQ, which is tangent to this hollow sphere. So 2 by 3 mr square plus mr square, this will give you 5 by 3 mr square. ये समझा स्टूडेंट्स आपको? एंड एज पर द डेटा मैंने ये भी समझा दैट आई, ये ध्यान से बेटा, आई इज द मोमेंट ऑफ इनर्शिया ऑफ द डिस्क अबाउट इट्स डायामीटर. दैट मीन्स जो आंसर उन्होंने x बाई 15 आई गिवन है, राइट, वो आई एक्चुअली वैल्यू है एम आर स्क्वायर बाई 4 का. सो दिस विल बी यूजफुल जब हम पूरा सॉल्विंग कर लेंगे, मे बी इन द थर्ड लास्ट और द फोर्थ लास्ट है, देखते हैं, राइट. सो फॉर द ओवरऑल सिस्टम, फॉर द एंटायर सिस्टम, राइट, moment of inertia of the entire system will be, students, moment of inertia of A plus moment of inertia for B plus moment of inertia for C. Who is A? Disk. Who is B? Solid sphere. Who is a C? Spherical shell. That is hollow sphere, right? वही आपने सॉल्व भी किया स्टूडेंट्स. सो आई विल सजेस्ट आप पहले से ही स्टूडेंट्स एम आर स्क्वायर ले लो कॉमन. यू कैन डू दिस, राइट. सो आई ए में आपको मिलेगा 1/4, आई बी में आपको मिलेगा स्टूडेंट्स 7/5, आई सी में यू विल गेट 5/3. ये ठीक है स्टूडेंट्स. सो दिस विल बी लाइक 5 plus 4 into 7 is 28 divided by 20 plus 5/3 the whole multiplied by mr square. Okay students, so this will look like 33/20 plus 5/3 the whole multiplied by mr square. Alright students, okay, so this will be 33 into 3, that is 99, plus 20 into 5 will give you 100, the whole over 60. This should be multiplied by mr square as it is. Alright, so this will look like 199 divided by 60 multiplied by mr square. So this is students moment of inertia of the entire system, 199/60 multiplied by mr square. But let me remind you, instead of mr square by 4 हम क्या लिखने वाले थे? I. Look at this data students. Instead of mr square by 4 we were supposed to write I. Yes, so obviously mr square we can replace by 4i. Getting this students? इसको यूज कर रहा हूँ मैं फिर से. mr square we can replace by 4i, mr square we can replace by 4i, right? So 199/60 you keep as it is, you multiply that by, instead of mr square, 4 times I. So this will look like 199 into I divided by 4 into 15 will give you 60. So moment of inertia of the entire system is equals to 199 divided by 15 multiplied by I. ये clear है students? I think as per the data ये value कुछ और है. As per the data this value is students x/15. Have a look here, x/15 times I. Yes, x/15 times I. क्या था बेटा? बोलो. x/15 times I. So just compare कर लो students. Yes, when you compare, 15 is there, I is there, so definitely the value of x is equals to 199. So value of this integer x is equals to 199. Okay, complete this students. x का वैल्यू मैं यहाँ पे ब्लैंक में डाल देता हूँ. The value of x will be 199. Okay, complete this students. A wheel is rolling on a plane surface. The speed of a particle on the highest point of the rim is 8 meter per second. The speed of the particle on the rim of the wheel at the same level as the center of wheel will be, option A 4 meter per second, option B 8√2 meter per second, option C 8 meter per second, option D 4√2 meter per second. This MCQ came in 4th April shift to 2025 JEE mains examination. Students, let me label this lowest point as A, highest point as B, and point midway as C. Alright, or we can do one thing, let me label this center as C. Fine, and ये पॉइंट को लेबल कर लेते हैं फिर D. सो सेंटर इज द C एंड मिडवे मतलब सेंटर के लेवल में जो राइट की तरफ आपको पॉइंट दिख रहा है, दैट पॉइंट इज D. इतना समझेगा स्टूडेंट्स को? So can I say velocity at A will be 0, because velocity of a center of mass, okay, is towards right, while r omega is towards left. So net velocity will be, sir, net velocity will be v minus r omega at point A. All of you agree with this? But for pure rolling motion, as per the data, value of v and value of r omega will be same only. So v minus v will give you 0, right? So velocity at point A, that is lowest point, is 0. Getting this? Now students, what about highest point B? At highest point B, the velocity will be Vb, which is equals to velocity of center of mass V plus r omega. But as per our recent discussion, for pure rolling motion, V and r omega are same only. So V plus V will give you 2V basically. Now as per the data, in second line उन्होंने आपको एक value दिया है 8, right? The speed of the particle on the highest point of the rim is 8 meter per second. So 2V is equals to 8 meter per second. So can I say this applies, the value of V will be 4 meter per second. 2V is equals to 8, so V can give you 4, obvious. So the value of V is equals to 4 meter per second. Is this the requirement? No. The speed of the particle on the rim of the wheel at the same level as the center of wheel, that means उनका demand है velocity at D. First of all, can I say students, velocity for center of mass is VCM, जिसको हम यहाँ V consider कर रहे हैं, which is again towards right. Alright, where is r omega right now? At point D, it will be along negative y axis. तो आप मुझे बता सकते हैं net velocity कैसे मिलेगा बेटा आपको भी? Yes, what is the net velocity of these two, V and r omega? Come on, using basic knowledge of vector, आप उसको V net लिखोगे, and V net का magnitude क्या होगा students बोलो? V net will be under root of V square plus r omega the whole square. But we know the story now, pure rolling motion, right? So V and r omega are numerically same only. So this will become root of V square plus V square, that is 2V square. So total will be root 2 multiplied by V. And recently हमको V का value मिला, कितना मिला बेटा? It is 4 meter per second. So root 2 multiplied by 4. So overall your answer will be 4 root 2 meter per second. So this is the net velocity at which point, sir? At point D. So आप label कर लो उसको VD. Yes, net velocity at point D, magnitude आपको मिल गया 4 root 2 meter per second, right? So this is going to match with option D ना बेटा, check करो. Option D, yes, option D, 4 root 2 meter per second. Simple question. Yes, complete this. A force of 49 Newton acts tangentially at the highest point of a sphere solid of mass 20 kg kept on a rough horizontal plane. If the sphere rolls without slipping, then the acceleration of the center of the sphere is how much? Option A, 2.5 meter per second square. Option B, 0.35 meter per second square. Option C, 0.25 meter per second square. Option D, 3.5 meter per second square. This MCQ came in 3rd April shift 1 2025 JEE mains examination. Alright students, here I can start with the basic formula of tau, torque in our rotational motion. Tau is equals to I alpha. Yes, you remember this? Tau I have used for torque, that is equals to I alpha. I is moment of inertia, while alpha is angular acceleration. Alright, now यहाँ पे it is clearly specified that the sphere rolls without slipping. That means मैं tau को लिख सकता हूँ students, F multiplied by R perpendicular. Students, what is the distance between these 2 points, lowest point and highest point? This is nothing but, आपने चेक किया ना students, lowest point है वो fixed एट हाईएस्ट पॉइंट यू आर अप्लाइंग द फोर्स, राइट. सो बेसिकली आप जब टाउ लिखते हो आप ऐसा लिखते हो ना, एफ मल्टीप्लाइड बाय आर परपेंडिकुलर. एंड हाउ मच इज आर परपेंडिकुलर, टेल मी. दैट इज नथिंग बट diameter of this solid sphere, which is definitely 2 times the radius. So basic formula for tau is I alpha, वो मैंने start किया. Then instead of tau I am using f into r perpendicular. And sir, r perpendicular is not r. Check the diagram, okay? That's 2r. That is equals to, students, moment of inertia I as it is multiplied by alpha. Okay, we can do one thing, students. हम यहाँ से alpha eliminate करने को try कर सकते हैं. Do you know that a will be equals to r alpha? Yes, students. क्या कहते हो आप इसे? This is the relation between linear and angular acceleration. A is equal to r alpha. So instead of alpha, can I use, students, a by r? Can I do that? It is a by r. All right. So I think आप थोड़ा इसको simplify कर सकते हैं before substituting the values and all. आपको क्या ढूंढना है, students? Let me remind you. आपको ढूंढना है acceleration, right? Acceleration of the center of the sphere is. So we have to find out a. So formula for a will look like this, students. 2f r into r will become r square divided by I. Getting this, students? So formula for a आपको मिल चुका. That's 2fr square divided by I. Yes, sir. So let me first substitute this formula of moment of inertia, 2fr square. Students, what is the formula for moment of inertia for solid sphere? Mind you, it is about tangential axis, central axis nahi. It will be 7 by 5 mr square. Yes, sir. It is rotating about its tangent. Yes. So it is 7 by 5 mr square. I am using this as the formula for moment of inertia of the solid sphere, right? I think radius small r है ना, ठीक है, तो मुझे यहाँ small r लिखना चाहिए. No problem, sir, लिख देते हैं. So this is small r. All right. So as you can observe here, r square will cancel out, right? Mass will remain, force will remain. So this will look like, in the next step, 10 by 7 into f by m. All right, students. So acceleration a will look like 10 into, sir, what is the value of force given to you? That's 49 Newton. 49 divided by 7 into mass. Mass का value है, students, second line देखो, 20 kilogram. All right. So some simple cancellation we can do now. So यहाँ से आप एक ज़ीरो कैंसिल कर लीजिए पहले तो. Okay, then 7 into 7 can give you 49. So therefore a will look like, students, 7 by 2. That is obviously 3.58 is. So unit will be meter per square second. So the required value of acceleration is 3.5 meter per square second. So this is going to match with, students, 3.5, right? Option D. A cord of negligible mass is wound around the rim of a wheel supported by spokes with negligible mass. The mass of wheel is 10 kilogram and radius is 10 centimeter and it can freely rotate without any friction. Initially the wheel is at rest. If a steady pull of 20 Newton is applied on the cord, the angular velocity of the wheel after the cord is unwound by 1 meter would be: option A 0 radian per second, option B 10 radian per second, option C 30 radian per second, option D 20 radian per second. This MCQ came in 2nd April shift 1 2025 examination. Students, first of all, यहाँ clearly बताया जा रहा है the mass of wheel is 10 kilogram, right? And radius is 10 centimeter. So for the wheel, mass m is 10 kilogram and its radius r is 10 centimeter, that is 10 raised to minus 1 meter. F value given to you, diagram में भी दिख रहा होगा आपको, it's 20 Newton. Wheel was initially at rest, right? So omega naught, that is initial angular velocity, is 0. Alright, ये last line देखा आप लोगों ने. After the cord is unwound by 1 meter, we can use this data to calculate theta, angular displacement theta, in some time. But उसके पहले एक और noticeable point है, students. cord of negligible mass is wound around the rim of a wheel supported by spokes with negligible mass. So mass of spokes is given negligible. So definitely ये जो wheel है उसे मैं एक ring consider कर सकता हूँ. Yes, it's not a disc, it's a ring. ये समझा आपको? Alright. So let me start with the initial calculation related to moment of inertia. Guys, for the ring, moment of inertia I will be mr square. Yes. So this will be 10 kilogram into 10 raised to minus 1 square, that is 10 raised to minus 2. So total I will get 10 to the power minus 1 kilogram meter square. This is the moment of inertia I. Alright. Next, can I find out torque tau now students? देखिए टॉर्क के मेरे पास वैसे तो दो फॉर्मूले होते हैं, आर वेक्टर क्रॉस एफ वेक्टर. मैग्नीट्यूड वाइज क्या बोलेंगे आप? टाउ इज आर एफ मल्टीप्लाइड बाई साइन थीटा, राइट? सो इट्स आर एफ मल्टीप्लाइड बाई साइन थीटा. नाउ फॉर श्योर स्टूडेंट्स द एंगल बिटवीन अप्लाइड फोर्स एफ एंड आर वेक्टर इज 90 डिग्री. करेक्ट है? समझ में आ रही बात? सो थीटा विल बी बाई डिफॉल्ट 90 आर एफ साइन थीटा. एंड सेम टॉर्क को पता है ना हम लोग आई अल्फा लिखते हैं बेटा. यस. सो व्हाट यू कैन डू नाउ, इनफैक्ट अगर आपको ये आर को एक्सटेंड करना है आप कर सकते हैं. आर वेक्टर इज दिस, राइट, एंड दिस इज योर एफ वेक्टर. बट जैसा मैंने आपको बताया जो एंगल है वो तो बाय डिफॉल्ट 90 है ही, जिसमें आपको और इसको एक्स्ट्रा बता रहा था, राइट. सो आर विल बी इनफैक्ट स्टूडेंट्स टाउ विल बी आर एफ साइन 90 दैट इज इक्वल्स टू आई अल्फा. सो दैट मीन्स रेडियस इज 10 raised to minus 1 मीटर. Applied force is 20 Newton, sin 91 है, that is I. Moment of inertia is 10 raised to minus 1 multiplied by alpha is unknown right now. So alpha will be students 20. Getting this? The value of alpha is 20 and yes it's alpha, so unit will be radian per second square. Obvious. Alpha मिल गया students को 20 radian per second square. So using the knowledge of I you found tau and then tau के दो फॉर्मूले इक्वेट करके we found alpha. एंगुलर एक्सीलरेशन अल्फा 20 रेडियन पर सेकेंड स्क्वायर. नाउ मैं क्या सोच रहा था स्टूडेंट दैट वी कैन यूज थर्ड काइनेमेटिकल इक्वेशन फॉर रोटेशनल मोशन. बट देयर इज वन प्रॉब्लम इन दैट, टिल नाउ आपको थीटा नहीं पता है. सो फॉर दैट आई कैन यूज योर फॉर्मूला रिलेटेड टू प्लेन एंगल, राइट. सो थीटा, प्लेन एंगल थीटा को हम कह सकते हैं स्टूडेंट्स लेंथ ऑफ आर्क. ओके, इट्स लेंथ ऑफ आर्क डिवाइडेड बाय radius. Yes, you all know this. So length of arc is given to you 1 meter. Check this. मैंने कहा था इसको यूज करेंगे हम in some time. 1 meter divided by the radius is 10 raised to minus 1 meter, right? So this will be 10 and the good part is ये formula से directly we will get theta in SI unit which is nothing but radian. So theta will be 10 radian students. This is not the final answer. Let me remind you आपको ढूंढना है final omega. Yes, the angular velocity of the wheel after the cord is unwound by 1 meter would be, so final omega is omega only, omega is question mark. So let's use third kinematical equation now for rotational motion that looks like this. Omega square is equal to omega naught square plus 2 alpha theta. That means omega square will be omega naught is 0, right? So 0 square plus 2 alpha sir 20, ये रहा अल्फा 20 रेडियन पर सेकेंड स्क्वायर इंटू थीटा इज योर 10 रेडियन. सो दैट मीन्स ओमेगा स्क्वायर विल बी स्टूडेंट्स 400. yes, so taking square root on both sides I will be getting omega as 20 radian per second. So the required angular velocity, that is final angular velocity, omega is 20 radian per second, and that's why this is going to match with option D. Complete these students. 20 radian per second, this is your answer. Okay. Next question now. A circular ring and a solid sphere having same radius roll down on an inclined plane from rest without slipping. The ratio of their velocities when reached at the bottom of the plane is under root of x by 5, where value of x is question mark. This question came in 4th April shift 1 2025 examination. Students, I think this is a formula based question. जल्दी से solve हो जाएगा आप लोगों से. So this is related to rolling motion, right, on an inclined plane. Now formula for velocity in this situation will be v is equals to under root of 2gh divided by 1 plus k square by r square, correct? What is k? Let me remind you, k is radius of gyration, right? Now मैंने देखा there are two different structures out there. One is circular ring and another is a solid sphere. But can I say 2gh, ये तीनों terms तो same है for these two structures, alright? Roll down on an inclined plane, same inclined plane है दोनों के लिए, तो h का वैल्यू कॉमन ही हो गया, राइट? सो जस्ट आप एक काम कर लो, आप मुझे बता दो व्हाट इज k स्क्वायर बाय r स्क्वायर फॉर अ रिंग, एंड देन सेम वे व्हाट इज k स्क्वायर बाय r स्क्वायर फॉर अ सॉलिड स्फीयर. फॉर अ रिंग k स्क्वायर बाय r स्क्वायर इज 1, एंड स्टूडेंट्स फॉर अ सॉलिड स्फीयर, राइट, सेम k स्क्वायर बाय r स्क्वायर विल बी 2/5. so this is for a 2/5, right? This is for a solid sphere. This simply means velocity का ratio will look like this: v divided by v, right? It's ring divided by solid sphere का velocity. So this will be root of, students, 1 plus k square by r square for the solid sphere, which is 2/5, over 1 plus k square by r square for a ring is nothing but 1. Just as you can observe, 2gh everything is constant, so v will be inversely proportional to square root of 1 plus k square by r square. Obvious? That is the reason LHS में मैंने velocity किसका ढूंढा ratio? Ring divided by solid sphere. But on RHS I took solid sphere divided by ring because relation is inverse. Obvious? So next step थोड़ा maths करना है आपको. This will look like root of, students, 7/5 divided by 2. Alright? Now as per the data, the same value is, students, root x by 5. Can you find this? Root of x by 5. Just compare this, you will get to know that the value of x is 7/2 because 5 तो common दिख रहा है मुझे दोनों के denominator में. So x is the value of x is 7/2, that is 3.5. So the required value of x is 3.5, right? But as we know, this is integer type question, so I can round off this to 4. So you can go with this value, x is equals to 4. So this is your answer. Integer will be 4. So the value of x here will be 4. Alright. A thin solid disc of 1 kilogram is rotating along its diameter axis at the speed of 1800 rpm. By applying an external torque of 25 pi Newton meter for 40 seconds, the speed increases to 2100 rpm. The diameter of the disc is dash meter. This question came in 8th April, shift to 2025 examination. Alright. So as per the data, students, it's a solid disc whose mass is 1 kilogram. Initial frequency, let me denote this by Fi, right, is 1800 rpm. Then final frequency, let me consider that as Ff. Final frequency Ff is 2100 rpm. Right. Now the applied torque tau is 25 pi Newton meter. For how much time? That's 40 seconds. So small t time is 40 seconds, right, students? Then the diameter of the disc is the requirement. D is question mark, students. Diameter of the disc, right? ये आपको यहाँ पे ढूंढने बताया जा रहा है, right? So I think we can start with the discussion of kinematical equation, students. Yes, I think first kinematical equation for rotational motion will be best over here. Omega final is equals to omega initial plus alpha times t. Yes sir, omega final is omega initial plus alpha times t. इससे स्टूडेंट्स आपको अल्फा मिल जाएगा. देन यूजिंग द फॉर्मूला फॉर टॉर्क टाव इज इक्वल टू आई अल्फा, आपको आई मोमेंट ऑफ इनर्शिया मिल जाएगा. देन यूजिंग दैट वैल्यू ऑफ मोमेंट ऑफ इनर्शिया वी कैन फाइंड आउट द रेडियस एंड देन डबल करके वी विल गेट द डायमीटर. So this is the sequence that we are going to follow. First of all, I am using first kinematical equation for rotational motion जो मैंने आपको बताया recently. Omega final is omega initial plus alpha times t. That means students, omega final minus omega initial divided by time is alpha. Obvious. So alpha will be, let me take 2 pi common. So alpha will be 2 pi into final frequency minus initial frequency the whole over time. Alright. So that means angular acceleration alpha will be 2 pi. So what is the final frequency? That's 2100 rpm. So I just have to divide by 60 so that मुझे unit rps दिख जाए. rps revolutions per second. So 2100 divided by 60 can give me 35, right? So 35 rps. What about the initial frequency? 1800 divided by 60, that will give you 30 rps. Obvious. So 2 pi I took common. Final frequency students 35 minus initial frequency is 30. Let me divide this by time. The given value of time is 40 seconds. Alright. So this will be students 2 pi multiplied by 5 divided by 40. So 10 into 4 is 40. So this will give you pi by 4 students. So alpha is pi by 4 radian per second square. Getting this students? Angular acceleration alpha is pi by 4 radian per second square. Okay, getting this my students? Yes, I think हमारा डील हुआ था that हम अल्फा कैलकुलेट करके टॉर्क जो गिवन है उसका यूज़ करके टाव इज इक्वल टू आई अल्फा में सब्स्टिट्यूट कर लेंगे. सो वी कैन गेट मोमेंट ऑफ इनर्शिया आई, राइट? सो टेल मी बेसिक फॉर्मूला फॉर टॉर्क टाव is equals to I alpha. So moment of inertia I will look like tau divided by alpha. Torque का value given to you is 25 pi Newton meter divided by alpha, which is pi by 4 radian per second square. Pi we can cancel out. हमें मिलेगा students 25 into 4, that is 100, correct? So moment of inertia I will be 100. What is the unit? Come on, kg meter square. Getting the students? Moment of inertia 100 kg meter square. What next now? Diameter of the disc is what we have to find out. तो radius पता कर लेंगे using this value of moment of inertia. Obvious. But क्या आपने ये ध्यान से read किया first and second line students? A thin solid disc of 1 kilogram is rotating along its diameter axis. So for the solid disc, right, moment of inertia about the diameter axis I can use 1 by 4 mr square. Yes students, getting this? Now tell me, id moment of inertia जो आपको मिला वो है 100, this above value 100, this is equals to 1 by 4 into the given mass is this 1 kilogram students into square of radius, right? So this will give you students 400 is equals to r square. Just taking square root of both sides मुझे radius मिल जाएगा 20 meter. But let me remind you, they are demanding diameter, right? So one more step now. So diameter is equals to 2 times the radius, 2 times 20, that will give you 40 meter students. So the required value of diameter is 40 meter. So ये जो blank उन्होंने आपको दिया है, right? The diameter of the disc is dash meter. वो dash में जो integer आएगा that will be 40. Complete these students. 40 meter, this is the required diameter का answer. 40 meter, 40. Complete this. A solid sphere with uniform density and radius r is rotating initially with constant angular velocity omega 1 about its diameter. After some time during the rotation, it starts losing mass at a uniform rate with no change in its shape. The angular velocity of the sphere when its radius becomes r by 2 is x times omega 1. The value of x is dash. This question came in 4th April, shift to 2025 examination. So first of all students, आपको यहाँ पर रेडियस का डेटा गिवन है r/2, उससे आपको मास का डेटा निकालने आना चाहिए, राइट? So let me go in a stepwise manner. So it's a solid sphere where density is uniform, alright? Its radius is r, alright? Now what happens is its initial angular velocity is omega 1, yes sir, about its diameter. ठीक है students? अब क्या हो रहा है students? It is losing mass and the shape is not getting affected. मतलब both the times shape जो है वो solid sphere है, so moment of inertia आपको पता है same रहेगा 2/5 mr². What next? Its radius is becoming r/2, जो मैं आपको एक मिनट पहले बता रहा था. Its radius is becoming r/2. Now can I say students, for a solid sphere rho will remain constant? Yes, rho is your students पता है ना आपको, volume density, this will remain constant. Now basic formula for volume density rho is mass per unit volume, alright? So can I say radius is becoming r/2, r is becoming r/2 basically. So volume of the sphere will be 4/3 pi r cube. So when radius becomes half, can I say volume becomes v/8, and because of that mass will become m/8 times. ये मैं कह रहा था students आपसे. So radius is becoming half, because of that volume is becoming 1/8 times, and because of that mass is becoming 1/8 times. Getting the students? Because density should remain constant, so mass per unit volume should remain constant. वॉल्यूम अगर 1/8 टाइम्स होगा तो मास भी तो 1/8 टाइम्स होगा. क्लियर है? नाउ टेल मी, यहाँ पर कैन आई यूज लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम? यस, लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम स्टूडेंट्स. What is tau external over here? Come on, 0 only. That is the reason with confidence हम use कर सकते हैं, right? Law of conservation of angular momentum. Alright? In that situation मैं कह सकता हूँ students, angular momentum initial value is equals to angular momentum final value. Alright? Now for angular momentum initial I will use I1 omega 1, and final angular momentum LF will be I2 omega 2. Getting the students? Now what is moment of inertia I1 students? Initial one, tell me. 2/5 mr² into omega 1 as it is. Now that is equal to moment of inertia I2, final moment of inertia I2. So 2/5. Yes students. What about the mass? Mass is becoming 1/8 times. Check this, m/8 लेना पड़ेगा फिर आपको. final mass is m/8. 2/5 into mass into square of radius. How much is the radius? The new radius now, it's half as compared to the original one. So 2/5 into mass into radius ka square, that is r/2 the whole square. Getting the students? Into omega 2 as it is. Alright, so we can do some cancellation now here. 2/5 will cancel out, m will cancel out, right? Radius square सिंप्लीफाई करके कैंसिल करते हैं फिर. सो r² इंटू ओमेगा 1 स्टूडेंट्स विल गिव यू 1/8 इंटू r² डिवाइडेड बाई 4. एंड एज पर द डेटा आपने देखा होगा दैट ओमेगा 2 का जो वैल्यू है, राइट, ओमेगा 2 इज x टाइम्स ओमेगा 1 स्टूडेंट्स. येस, सो ओमेगा 2 आई कैन रिप्लेस बाय x टाइम्स ओमेगा 1. गेटिंग दिस? सो नाउ r² विल कैंसिल आउट, राइट, omega 1 will also cancel out. So you will be getting students 1 is equals to 1/32 into x, right? So just doing this cross multiplication now, we will be getting x is equals to 32. So the blank is containing x, right? X is how much? So the required value of x is 32. So I can just substitute now. The value of x is 32. This is your answer. Okay.